On this worksheet, we're going to practice writing the formula of conjugate bases from these conjugate acids. So we want to write the formula of the conjugate base that is formed when each one of these acids donates one of its hydrogen atoms, or protons, H pluses. So if we're starting with an acid and we are converting our formula to a conjugate base, we're going to do that by removing one of the hydrogen atoms from the formula, and also we want to deduct +1 from the charge. This is because when the acid acts as an acid, that means that it donates or it loses an H+. So we want to remove the H, and we also want to remove the +1 charge for the donation of the H+. So if we are starting with H2CO3, we want to remove one of the hydrogen atoms. That's going to leave us with just HC3O. And then we also want to deduct +1 from the charge. This started as a neutral molecule, and so we want to subtract +1 from that initial neutral charge. So that's going to leave us with a charge of -1. For NH4+, we want to remove one of the hydrogen atoms, so that will take us down to NH3. And then also we want to deduct from that charge. We're starting with a +1 charge, and we want to deduct +1 from the +1 charge. That's going to leave us with a neutral molecule, no charge. And then last but not least, we have H2PO4 with a minus charge. We want to remove one of the hydrogens, so that's going to be HPO4. We already have a -1 charge, and we want to deduct another from that, so that's going to take us down to a -2 charge. Now, if we're going in the opposite direction, so we're being given the formula of bases and we are being asked to write the formula of a conjugate acid if we're going this way. So if we start with a base and we're being asked to turn it into a conjugate acid, we want to do the opposite of all of these steps up here. So this means that we want to add one hydrogen atom to the formula, and this means that we want to increase our charge by +1. And the reason for both of these things is because by definition, the base is the substance that took or accepted the donated H+. So this is what accepts the H+, so that means that we are going to be increasing the number of hydrogens by 1, and we're also going to be increasing the charge by 1 as well. So down here, if we are writing the formula of a conjugate acid for NH3, we want to add a hydrogen atom to that formula. So instead of NH3, it's NH4. We also want to increase the charge by +1. We started with no charge, so we want this charge to go up from 0 to +1. For ClO3-, we want to add a hydrogen atom to this molecule, and typically if there aren't any hydrogen atoms already present in the molecule, the hydrogen is going to come first. HClO3, and for our charge, we're starting at a -1. We want to increase the charge by +1. That's going to take us up to a neutral charge. And last but not least, SO4(2-), we want to add a hydrogen atom, SO4, HSO4, and we want our charge to increase by +1. We're starting with a -2 charge, increase it by +1, that's going to take it to a minus charge.